Jenkins. As you know, Jenkins is called as what? CI CD tool, continuous integration or continuous delivery or deployment. You'll understand what do you mean by continuous integration, continuous delivery. Okay. Now, so far till Maven class, this is what we have done. Here we received the code from the development team, basically here, and then we store the code in Git. Git is the place where we store complete application code. Here we have source code, correct? Source code can be anything, right? It can be Java, C, C++, or anything, okay? HTML and things like that. We clone the code. First thing is what? We clone it. Once we clone, we have executed that mn install command, right? And mn install command creates given package. Usually in web application, we create what? Var file. We have also created the var file, that is gamut.var file, and we have manually deployed it. So second thing is build the application. Third thing, we have deployed it. And you remember this, right? We have executed all these 3 steps one by one manually. First we clone, that's a manual. Manually you have to run this particular mn install command, then copy this particular var file using a CP into this Tomcat server. In Jenkins, we are going to configure all these 3 steps so that the build and deployment can be executed in a continuous fashion. We call that as continuous integration. Why Jenkins? First thing, right? So why cannot use some shell or Perl script and then trigger all these things together? Jenkins, apart from executing the build and deployments in a continuous fashion, it has a lot of other features also. For example, you can see the complete build and deployment information in your the browser dashboard. You can go and then start the build, stop the build, and you can check a lot of the build and deployment information there. It also acts as kind of the reporting tool. So how many builds failed, how many builds passed, right? You can see your test case results there. You can send email notification to your stakeholders whenever build and deployment is done or fails and things like that. A lot of functionalities you have. Apart from all these features, right? The real the important feature that Jenkins uses, that continuous integration, continuous delivery or deployment thing. What is that continuous integration, right? You see this. For example, there is a developer, okay? Developer commits the code, commits something at 2 a.m. to your Git. For this developer to test the code, somebody has to build it and then deploy it, correct? Then only this guy can go and then launch the application and then test. So the question comes, how do you trigger the build as soon as developer commits something into Git? If right, it is a human, it's very difficult for us to continuously monitor for the new changes. You can write shell script or Perl scripts, but you have to do more and more automation for that, right? It takes more time for you to write the code and a lot of things basically. That's where we bring Jenkins into picture. If you have Jenkins, you know what you can do? You can configure Jenkins in such a way that it continuously monitors for the new changes which is coming in the Git or any other version control system. The moment it detects a change, you can configure it to clone it, build it, and then deploy it without you manually doing anything there. So basically, it is helping you to continuously execute this build and deployment. Okay, so where Jenkins come in this end-to-end build and deployment? This is the Jenkins server. This is where you perform your builds. Jenkins is the place where you execute the builds. So earlier we used to call it the build server. Now let's call it as Jenkins server. Jenkins server. That means we take a machine, we go and then install Jenkins in this particular machine, and we do execute all builds here. And we have the var file in this particular machine. Once var file is created in Jenkins server, then we copy that to Tomcat servers. That is deployment. So Jenkins is basically a browser application. So once you install Jenkins in this particular machine, you can access Jenkins in your browser. and you can create something called project, or you call it as a job, or you call it as pipeline. Okay, pipeline, project, job, or pipeline. So you understand this, right? It's a Jenkins mission. I install Jenkins and then I launch Jenkins in the browser, right? As a DevOps engineer. This is me. In the browser, I can go and then create this project. It's like GUI tool, okay? Using some GUI options, you have to go and then configure everything. In this project GUI, you first go and then give your Git URL wherever you have the source code. This Git server's URL. Basically, we are integrating clone, build, deployment steps in one place. So as a DevOps engineer, you create a project or pipeline, you put your Git URL, then you give your EMI install command here. Okay, that is build command. Build command. Then you can give your deployment commands here. Deployment related commands, your SCP command to SCP command, which will copy the WAR file to Tomcat server. And you can also set up the notifications, basically notifications. That means when you run the build, assume that there is some compilation error. If you have this notification set up, it will automatically send email to the development teams and QA teams. Or you want to send the email, after the deployment is successful or failed or whatever. You can configure all those, users' email IDs, notifications basically. You can also give some schedule if you want schedule. What time you want to trigger the build? You can also give that. You can give, the schedule basically. I mean the planned schedules. Morning, say 7:30, I want to trigger one build. Evening 5:30, I want to trigger one more build. That's a planned build. You can give that. Or you can also change the schedule in such a way that Jenkins continuously checks Git for every 5 minutes or 10 minutes. And if it detects a change, it will take the code, build, and then deploy it. We can configure all those things. Right. In this particular use case, assume that user has submitted something at 2 a.m. So what I can do in my Jenkins, I can configure it in a way that it talks to this Git for every 5 minutes. I can configure that. All those configurations we'll see later. So what Jenkins do, it will go to the Git, it will ask it, Mr. Git, do you have any new change? It says, I don't have any change. It will come back. Again, after 5 minutes, it will go. We call this as polling. Polling means continuously checking something, hitting something. It will go to Git again. Do you have any new change? It's a 2 a.m. Git says, okay, I just have few commits. It knows what commit it has taken in the last bit. It records everything. Jenkins. The moment Jenkins identifies that there is a new change, it will automatically clone it. And how it knows to which Git repository it has to connect? We have given the Git URL right here. So to the given Git URL, it will continuously say hit. So the moment it finds a change, it will take the code, then it will execute this build command that you have given, then it will execute this deployment command, then it will send notifications. So whatever you have configured in your project, it executes everything. So beautiful, right? So without your supervision, without you supervising it, or without you, manually doing anything, it is automatically executing the process. We call this as what? CI. Okay, let's think about some definition. What is continuous integration? Continuous integration is a process which will detect the change coming into any version control system, take the code, build the code, deploy the code into given environment seamlessly without any manual intervention. We call that as continuous integration, right? It is not just that, right? If you don't have the CI, continuous integration, if you don't continuously do the build, right, you get a lot of other issues also. If you have the CI, what happens, right? You can, so with it's everything is automation, right? You can also do this. For example, say this is a QA environment, right? You deploy it. The moment 2 a.m. code comes, you have deployed it to QA. Once it is deployed to the QA, you can go and then run some test cases. Basically, you run some test cases. Once these test cases are passed, you can also automatically push that same WAR file. This WAR file is here, right? And this WAR file is good because test cases are successful. Once it is successful, you can also move that to the production or to a set environment. Again, you do something there. Again, if something is good, then you push it to prod. So without anybody's manual intervention, your code is continuously built, your code is continuously deployed, your code is continuously tested, and then your code is continuously going live to end users. You can do this. If you go to Amazon, Google kind of technology centric companies, right? They aim to push the developer's code right to the production within 2-3 hours. Whereas in some companies, it will take weeks, months. Assume that developer develops cash and delivery feature, right? What if you push it to the prod within say 2 hours? You can generate a lot of revenue out of it. There is some issue in the production. What if you can push that particular right change to the production within 5 minutes or 10 minutes, and even though like thousands of developers are working, right, your code is continuously going without anybody's say manual say intervention. Correct? It's a good, right? So basically you can achieve that time to market, right? Time to market means how soon you can push your code to the market. We call that the time to market. Whereas for some companies, even though developers have some code, right, it takes week, right, 1 month. So it's a right, it delays your development, it delays your testing, it delays your product live to the end users also. So continuous integration is very important in DevOps, right? In waterfall kind of models, right, we used to wait for 1 month release, 2 months release. Some companies do major releases, right, once in a year or right twice in a year. But with Agile means what, right? Agility. That means when you have many things, you split a smaller, say you split the complete release goal into smaller features, and then you develop independently. As and when some feature is ready, you have to push it on the same day or the same week. For example, agility, right? You take a goal and then you take a short sprint basically, and then push it as soon as possible, smaller things. So that helps basically. If the major release, if you are deploying 20 features at once, right? Even though 10 features are ready, right? You are still waiting for another 10 features because you want to push everything at once. And why? So when Agile is good, why people were doing this before? They were, they were forced to do it because that's a application design, and the processes, everything is based on that waterfall model. So in order for you to push the smaller changes to the production, you need to have that support from the coding side also. So those days, right, people used to design the applications in that way. These days it's all Agile. So in Agile, since we target to push the code as soon as possible, this continuous integration is very important for us. So there is another thing, right? It saves a lot of time, a lot of money, and a lot of things to you. I'll give you another use case to effectively recognize, right? So feel the importance of CI. For example, there's a developer, right? He pushes something at say 10 a.m. and you have triggered the build, right? Okay, so let me give you one scenario. You have planned builds, one at 7:30 a.m., second thing at 5:30 p.m. 2 times you are executing the builds. 7:30, you trigger the build, you deploy the code, right? Developer commits something at 10 a.m. When this particular change will go to the QA, only as part of 5:30 build. When you trigger the 5:30 build, this change will go, right? Okay. So 5:30 you have triggered the build, right? And then there is some compilation error. You report this compilation error to this particular developer. What happens now? Developer wrote this particular code at 10 a.m. this code, and thinking that assuming that this code is good, this guy has developed a lot of other code on top of this. He has written some piece of code, and then using this code he has developed a lot of other functionalities, right? And now 5:30 you go to the same developer and say your base code is wrong. That means what? This work is wasted when it's this idea itself is wrong. So developer says, right, I committed something at 10 a.m. and 5:30 you are coming to me and say that, oh, this code is wrong. Why, right? You are unable to give me the feedback, right, by 10:30 or 10:05, within 5-10 minutes or half an hour. If you had told me that this, code is wrong, compilation error, or it is not meeting the quality criteria, it is failing the test cases, right? So if you had given that feedback within within half an hour, right, I would have planned my other changes accordingly. And now you come and then say, right, that it is bad, and you wasted my whole day. See the impact now. So as a DevOps, right, we always strive to give a fast feedback to our developers, right? What is that? Fast feedback. Our system should be able to take the change, any change that comes. That's our aim, basically goal. Any change that comes, you should be quickly take it, build it, run some unit test cases, and then throw the feedback to the developers so that they can quickly identify the issue at early stages itself. They can fix the things. They can basically, right, do the trial and error multiple times in a day, right? 5 minutes, there is some issue, throw it. He will fix it. Again, he will commit. Again, right, within 5 minutes, you identify. Again, there is some issue, throw it back. See how many chances you are getting to your developer, right, to do some trial and error, to say experiment with something, right? If it is 5:30, if you are not very frequently, very quickly, right? So we call it as what? Fail fast, right? Fail early, right? As soon as possible, you have to fail it, right? As fast as possible, you have to fail it. It's not that the code went to the QA, then you identify some issue, and then you report it. So people, a lot of time and a lot of people have already worked on this, and a lot of time is wasted, a lot of manpower is wasted basically. What if you had built it and then ran some unit test cases and then, right, gets that change is bad and not qualified for the level of testing here itself, and then thrown it back to the developer? See, fail fast, fail early. So our DevOps, these are all the best practices, right? See, if we have 3-4 years of 3-4 years experience DevOps engineer, the guy don't worry about all these things, right? His job is, somebody asked me to, trigger the build, I've built it, I've deployed it. These are the best practices, right? Usually, the senior experts, right, the architects, DevOps architects and kind of people, right, think about these kind of best practices. Think to implement these kind of processes and then processes in the system basically. So we should always try to give the fast feedback to the users. And these are all the use cases, right, why it is very much required. So to solve all these use cases, only one thing, you should be able to trigger the build and deployment fast, and then as soon as possible you have to push it. And it's not possible for a human to continuously monitor for the change. So what do? We need some tool. And what is the tool here? That is Jenkins. Jenkins can help you to achieve that continuous integration fashion, right? Before I take your questions, let me differentiate what is CI, what is CD. It is very simple. If you are continuously taking the code and then deploying the code to the QA, right, we call it as CI, continuous integration. As I mentioned, some companies, they deploy the code to the they deploy the code to the QA, they run some test cases, and if test cases are successful, they deploy the code to the SIT. Again, from SIT to prod or whatever. If you are continuously deploying the code to the prod, we call that as what? Continuous delivery or deployment. There is again thin line difference between continuous delivery and then continuous deployment. One thing, if the continuous deployment is happening to the QA environment, you call it as what? CI. Sometimes, as I mentioned, then you run some test cases here. You can, say, configure those conditions. If 90% test cases are successful, then push it to prod. So this is your production. And this deployment is also continuously happening. You are continuously executing the test cases, and then if 100% is passed, for example, that's a threshold which you set up. If this is successful, then deploy to the prod. This is called what? CD, continuous deployment, CD. Again, as I mentioned, there is something called continuous delivery deployment. Very simple. If you are continuously, without any human intervention, if you are pushing the code, you call it as continuous deployment. Sometimes what we do, we deploy the code and then we trigger the test cases, and then there is a human intervention. So you don't believe in these test cases, even though all 100 all test cases are successful. You still want to verify a few things, right? Maybe your system may be very sensitive. You cannot rely on the test cases, right? If you have the right test case, if you have written the test case for testing some use case, then that's okay. What if you don't have the test case to test some use cases? Then you cannot rely on test cases, right? Even the 100% is successful. So in those kind of scenarios, sometimes people manually verify few things, and then they maybe again, it's not manual. Verification is manual. Again, they just have to go and click one button or one command they have to run. It will automatically deploy to the production. So usually we always do continuous delivery because production, right? We have to be very careful. So most of the times production deployments are manual. That is, cannot say manual. It's a single button click. That's all. You just click a button, it will go, right? If it is human who is pushing that code to the prod, we call it the delivery. And deployment means it's high level, automatic. It's more automatic. CI CD. People also interchangeably use these terms. Okay, CD means people call it as production deployment. CI means QA, deployment. CI CD. Now you know what is Jenkins, what is a continuous integration, continuous delivery deployment, and then what are the why CI CD is very important for any application, and the importance of CI CD in DevOps, right? So before I explain, right, Jenkins installation, if you have any questions, you can proceed. Next topic will install Jenkins. Then we'll be configuring all this CI CD. Whatever I have explained, all these things I'll be showing it to you. On what? Gamut card project. We have executed this Gamut card project in Maven class, correct? As I mentioned there, here we won't be manually triggering EMI install, nothing. So just click a button here in your Jenkins, it will execute. Or you configure this poll option for every 5 minutes or 10 minutes, it will get the job done for us.